Welcome to our deep dive, into uh, the world where AI and the human mind kind of like come together.
Yeah, the cutting edge. Like, how does AI stack up to us?
Exactly. And we've got a really cool mix of sources today,
Hmm.
research papers, some videos, even some pretty heated debates from AI folks out there.
Oh, yeah, some strong opinions for sure.
So we're on a mission to figure out how far we've actually come in building machines that learn and what's still missing, from that human intelligence recipe.
Right, what's the secret sauce?
Exactly. And one thing that really grabbed me was the research on object recognition SOAR. Scientists have been trying to crack the code of how our brains process what we see, especially in a region called the inferior temporal cortex, or IT.
Yeah, the IT cortex, it's like the key for recognizing objects in humans and across primates and figuring out how it computes. That's been like the holy grail for neuroscientists.
And get this, researchers at MIT, Dan Yemens and Jim DiCarlo, they build deep neural networks that can actually mimic those computations happening in the IT cortex. Yeah. And they've even hit human level performance on some object recognition tasks.
Wow, so it's like they're recreating how we see.
It seems that way, and it's incredible.
It is what's really fascinating is how these deep neural networks actually do it. They're trained on massive data sets of images and they learn to pick out features and patterns kind of like in a hierarchy, almost like how neurons in the IT cortex respond to what we see.
So does this mean we finally solved how our brains see the world?
Well, it's tempting to think so, but not quite. While these advances in deep learning are amazing, they don't tell the whole story of human intelligence.
Right, there's more to it than just recognizing objects.
Definitely deep learning is great, especially for things like recognizing objects or speech, even mastering games, but there are still parts of how we humans learn and think that even the most sophisticated AI systems don't get.
Okay, so what's missing? What's that secret ingredient that makes human intelligence so special?
Well, for one thing, we humans can build these like causal models of the world.
Causal models, what does that mean?
It means we don't just recognize patterns, we understand the why behind things.
Okay, so cause and effect.
Exactly. That
Yeah.
why is crucial for explaining and understanding at a deeper level than just recognizing patterns.
So we go beyond just seeing what's there.
Right. Take, for example, a classic Atari game like Frostbite. The one where you hop across those ice floes and build an igloo?
Oh yeah, Frostbite, a classic.
Humans can figure out the goals of the game pretty quickly. We understand we need to build that igloo, avoid obstacles, and we do all that without needing someone to tell us, hey, this is what you get points for.
Right, it's intuitive.
Exactly. We just
Okay.
use our understanding of cause and effect, like how things work and how other players act to make sense of the game.
And deep learning models can't do that.
Well, they need those rewards spelled out to learn.
So it's like we're constantly running a simulation of the world in our heads, predicting what will happen next based on cause and effect.
That's a great way to put it. These simulations we build, they're grounded in what we could call intuitive theories about how things work.
Okay, so we have built-in assumptions about the world.
Yeah, think of it as intuitive physics and intuitive psychology. We just inherently understand that objects have properties,
Yeah.
like solidity, and that other players act in ways to achieve their goals.
It's like we're born with a basic understanding of the world, and then we keep updating it as we experience more.
I like that analogy. Another key aspect of human learning is compositionality.
Compositionality, what's that?
It's our ability to take simple pieces of knowledge and combine them into more complex ideas.
So like building with Legos.
Exactly. Like when we see a new type of vehicle, we instantly know what it is because we can recombine familiar concepts. Wheels, a platform, handlebars, deep learning models. They often struggle with that kind of flexible thinking.
This makes me think about that study I read about humans and AI trying to learn new handwritten characters.
Oh, the character's challenge.
Yeah, they found that humans, given just a few examples of a new character, could learn it and even create variations, understanding which features were essential and which were just style.
Right. And the AI,
Deep learning models needed tons of data and still had trouble generalizing as well as humans.
they even created those visual Turing tests to see if people could tell the difference between human-generated characters and the ones made by AI.
And could they tell?
It was surprisingly easy, even for people who weren't calligraphy experts or anything. It seems humans have this built-in understanding of the little things in handwriting, the subtle variations that make it look natural, and AI hasn't quite figured that out yet.
So it's not just about the amount of data. It's about how we use our past knowledge and experience to learn faster.
Right. Absolutely. We weave those past experiences into how we learn in a way that AI just can't. And this difference in learning speed was also super obvious in that Frostbite challenge we talked about.
Oh yeah, you mentioned how humans pick up the game way faster than those deep Q learning networks or DQNs.
Yeah, exactly.
Yeah.
Even with tons of data and training, a DQN takes the equivalent of hundreds of hours of gameplay to reach human-level performance.
Oh, that's a lot of time.
Humans, on the other hand, can get those game concepts and strategies in minutes.
So we're much more efficient learners.
And it's not just speed, it's adaptability too.
Adaptability, what do you mean?
Well, humans can easily adapt to new goals or rules in Frostbite. Instead of building the igloo, we could try to get the highest score, or die as quickly as possible, or even touch every ice floe once. But DQNs, they're usually stuck with whatever goal they were trained on.
So we can play with the rules and invent new challenges because we understand the game's logic.
Exactly. That ability to merge pattern recognition with a deeper understanding of the world. That's another thing that makes human intelligence special.
But are you saying that deep learning, despite all its power, is just fundamentally limited when it comes to really thinking like a human?
Not necessarily. I think deep learning's strength in pattern recognition could be combined with more structured cognitive models, bringing together the best of both worlds.
For like a hybrid approach.
Yeah, imagine a system that has the raw power of deep learning for recognizing patterns working together with the causal reasoning and flexibility of a human-like mind.
Wow, that would be something else.
It would, and speaking of breakthroughs in AI, remember AlphaGo and how it dominated the game of Go? That was a huge moment for AI.
Yeah, I remember it was all over the news. It felt like a turning point.
AlphaGo showed what's possible when you combine deep learning with something called Monte Carlo tree search.
Okay, so that's how it beat those top Go players.
Right, a feat that people thought was decades away.
But I have a feeling there's a but coming.
Haha. You know me too well. But even AlphaGo, with all its amazing abilities, it shows that we still need deeper understanding and generalization in AI.
So where did it fall short?
AlphaGo is brilliant, but it's kind of limited to the standard rules of Go.
Ah, I see. So if you change the rules, it struggles.
Exactly. If you introduce even small changes, like different board sizes or tweaks to the rules, AlphaGo starts to struggle. It needs to be basically reprogrammed and retrained for each new variant.
So it can't adapt on the fly.
Right, but we can quickly adapt and come up with new strategies because we understand the core principles of the game.
So it's like we can apply our knowledge to new situations while AI is stuck in its programming.
That's a great way to put it. That's a key challenge in creating truly human-like AI. We need systems that can not only master specific tasks, but also understand the underlying principles well enough to generalize, adapt, and even be creative.
That's a tall order.
It is. There are lots of promising avenues to explore, though. One that's really exciting is scene understanding.
Scene understanding, that sounds pretty deep. What does that actually involve?
It's about going beyond just recognizing objects in an image. Like true scene understanding means grasping how those objects relate to each other, the forces at play, even the intentions of any agents involved.
So it's like understanding that a tower of blocks is going to fall over, or that a person reaching for a door handle wants to open the door.
Exactly.
Yeah.
To get that level of understanding, we need AI systems that can use those key ingredients we've been talking about, intuitive physics, psychology, compositionality, and causal reasoning. It's a tough challenge, but the potential is huge.
Yeah, I can see that. But before we go too deep into scene understanding, there's another thing that's been on my mind. You mentioned that humans are really good at something called learning to learn. Can you explain that a bit more?
Sure. Learning to learn, or meta-learning, is basically the ability to transfer knowledge and skills from one task to another. Like, we humans, we don't start from scratch every time we learn something new.
Right, we build on what we already know.
Exactly. We leverage our past experiences, those mental models we've built up to speed up the learning process.
So like if I've learned to play checkers, that might help me learn chess faster.
Exactly. Or if you've mastered riding a bike, that could make it easier to learn how to ride a motorcycle.
Makes sense. We're always building on what we've learned before, refining our mental models and applying them to new things.
Yeah.
That's what makes us such fast learners.
Right, and current AI systems, they tend to be much more task-specific. They might be amazing at a specific game or really good at recognizing one type of object, but transferring that knowledge to new tasks without a ton of retraining, that's where they struggle.
So the challenge is building machines that can learn how to learn, not just learn specific things.
Exactly. It requires a whole different kind of architecture, one that lets AI represent knowledge in a more abstract and flexible way so they can adapt and generalize like humans do.
This is all pretty mind-blowing. It makes me wonder if it's even possible to build a machine that can truly capture how humans learn and think.
It's definitely a super tough goal, maybe one of the toughest humanity has ever set for itself, but I think it's worth it, you know. The more we understand about our own minds, the better we'll be at building machines that can help us solve problems, maybe even help us understand intelligence itself.
That's an optimistic view. It seems like this whole quest to build human-like AI is as much about understanding ourselves as it is about creating new tech.
I totally agree. It's a journey of discovery, both inward and outward. As we keep exploring the frontiers of intelligence, we might find that the most amazing insights come not from the machines we create, but from the process of trying to create them.
Well said. It feels like this deep dive has already taken us on quite a trip, from the mechanics of how we see to the implications of building machines that think like us.
And we've only scratched the surface. There's so much more to explore, so many mysteries to unravel. But by embracing the challenge, by combining human ingenuity with the power of technology, I think we can unlock amazing possibilities for the future of intelligence.
Well said. And speaking of unlocking possibilities, I think it's time to turn our attention to something specific, a development that shows both how far we've come and how far we still have to go. Have you heard of differentiable programming?
Apps. Differentiable programming is super exciting. It's like this meeting point between deep learning and symbolic programming, offering a way to create AI that's more flexible, adaptable, and easier for us to understand.
For those of us who aren't familiar with it, can you give us a quick rundown of what it is?
Sure. Basically, differentiable programming tries to bridge the gap between deep learning's strength in pattern recognition and the reasoning abilities of traditional programming languages. It does this by making the programs themselves differentiable.
Differentiable. What does that mean exactly?
It means we can figure out how changes to the code of a program affect its output.
So we can see the cause and effect of code changes.
Exactly. And that's really powerful because it lets us use gradient-based methods, which are the core of deep learning, to optimize the program's structure and parameters. We can basically fine-tune its performance by tweaking its code directly.
So instead of just changing the weights of a neural network, we can actually change the program's code itself. That's pretty amazing.
It is. It opens up a whole new world of possibilities for building AI that can learn and reason in a way that's more structured and human-like.
Okay, I see the potential, but how does this connect to building machines that actually think like us?
Remember those key things we talked about for human intelligence, like causality, compositionality, those intuitive theories? Well, differentiable programming gives us a way to weave these very concepts into AI systems.
Can you give me an example?
Sure, imagine a program that simulates a simple physical system, like a pendulum. In traditional programming, you'd write out specific rules for how the pendulum swings, but with differentiable programming, we could use a neural network to learn those rules just by watching the pendulum move.
So the neural network learns the physics of the pendulum by observing it.
Exactly. And because the program is differentiable, we can use a technique called gradient descent to optimize both the neural network's parameters and the structure of the program itself. This allows the system to not only learn how the pendulum works, but also how to best represent that knowledge in a way that's accurate and efficient.
That's really cool. It's like the AI is discovering and understanding the world on its own, like a scientist doing experiments.
That's a great analogy. And that's a crucial step towards truly human-like AI. Differentiable programming lets us combine the power of data-driven learning with the structure and transparency of symbolic reasoning, so we could create AI that's both powerful and understandable.
It sounds really promising. But are there any hurdles to overcome before differentiable programming becomes more common in AI?
One challenge is scalability. Differentiating complex programs can take a lot of computing power. It also needs specialized tools and techniques that are still being developed. But the field is moving fast and researchers are making great progress.
So there's a lot of excitement around differentiable programming. Do you think it could revolutionize AI?
I think it has the potential to really push the field forward, especially in areas where we need AI that's not just accurate, but also interpretable, adaptable, and able to reason about cause and effect. Think about things like scientific discovery, personalized medicine, even creative stuff like composing music or writing stories. Differentiable programming could be a game changer in those areas.
This has been super insightful. But while the potential is exciting, I'm also wondering about the limitations. Are there things about human thinking that even something as advanced as differentiable programming might not be able to capture?
That's a great question, and it gets to the heart of what makes us human. While differentiable programming is a powerful tool for building more flexible and understandable AI, it's important to remember that it's still a computational approach. It relies on algorithms, data, and mathematical models to represent and work with knowledge.
So there's still a gap between how humans think and how even the most sophisticated AI processes information.
That's a question philosophers and scientists have been thinking about for ages. We still don't completely understand how the human brain creates consciousness, subjective experience, and the way we navigate the world seemingly so effortlessly.
It seems like the more we learn about AI, the more we realize how much we don't know about our own
Mm.
minds.
That's what's so cool about this field. The quest to build human-like AI isn't just about technology, it's a journey of self-discovery. By trying to recreate our cognitive abilities in machines, we gain a deeper appreciation for the amazing capabilities of the human mind.
Well said. On that note, I think it's time to wrap up this part of our deep dive. We have explored the key elements of human-like AI, looked into the potential of differentiable programming, and talked about the mysteries of intelligence itself. What a journey.
It really has been a fascinating exploration, uncovering what makes human intelligence special and how those insights are shaping AI.
We've only scratched the surface, but I'm curious, what does the future hold for human-like AI? What are the big implications of creating machines that could, maybe even surpass human intelligence?
That's the question, isn't it? Philosophers and scientists have been thinking about it for ages, and it's only getting more relevant as AI gets more advanced. It's a question with huge implications. Everything from consciousness to the future of work, even the survival of our species.
Wow, that's a lot to think about. I can see why it sparks so much debate.
Yeah.
But before we get too deep into those big existential questions, what about some more practical applications? You mentioned scene understanding as a big frontier for AI. How do you see that playing out?
Scene understanding could totally revolutionize so many parts of our lives. Imagine robots that can navigate a messy room and also understand what the objects in it are for. They could help with everyday stuff, provide companionship for the elderly, or even help surgeons with complex procedures.
That's incredible. And what about self-driving cars? It seems like scene understanding is crucial for making them safe and reliable.
Absolutely. A self-driving car that truly gets the nuances of a complex traffic situation, like anticipating what pedestrians, cyclists, other drivers will do that would change everything for transportation. Fewer accidents, less traffic, maybe even a whole new way of designing cities.
So scene understanding is like the key to unlocking a whole new level of AI.
I think so. It's about going beyond just seeing to actually comprehending, and enabling AI to not just see the world, but understand it. That's why researchers are so focused on developing AI that can grasp how objects relate the forces at play, even the intentions of others in a scene.
So let's say we figure out scene understanding. What other cool developments can we expect in human-like AI?
Another area with huge potential is autonomous agents, AI systems that can operate on their own in the real world, learning and adapting as they go.
Like robots that can explore a new environment, figure out the layout, and achieve a goal without instruction.
Exactly. Or imagine AI personal assistants that truly get what we need, anticipate our requests, and become a natural part of our lives. They could manage our schedules, keep us organized, even offer emotional support when we need it.
That would be amazing. But what about the big picture? How will human-like AI impact society as a whole? What kind of world will we live in when machines can think like us?
That's the million-dollar question, right? On the one hand, human-like AI has the potential to help us solve some of the world's biggest problems, like climate change, disease, poverty, inequality. It could lead to new scientific discoveries, innovations, even new forms of art.
Like a new renaissance powered by intelligent machines.
It's possible, but we also have to be realistic. It's not all going to be perfect. Along with the potential, there are downsides, ethical challenges we need to address.
Like what kind of ethical challenges are we talking about? This is a topic that makes a lot of people worried.
One of the biggest concerns is making sure AI systems align with human values. We don't want to create machines that optimize for goals that end up hurting humanity, even if those goals seem logical from a computational point of view.
Right. We need to make sure we're not accidentally creating something dangerous.
Exactly. And we also need to think about the impact on jobs. As machines get better at doing things that used to require human skills, we need to be ready for the changes that could bring.
Will AI create new jobs or lead to mass unemployment? It's a question everyone's asking.
There are no easy answers. It's a conversation we all need to be part of. We need to start thinking now about how to prepare people for the future, how to make sure everyone benefits from AI, and how to create a society where humans and machines can work together.
It sounds like the future of human-like AI is a mix of hope and uncertainty.
I think that's a good way to put it. It's a powerful tool with the potential for good or bad. The choices we make now will shape AI and how it affects humanity for generations to come.
So what can we do to make sure AI is developed and used responsibly, ethically, and for everyone's benefit?
We need to have open and honest conversations about the potential benefits and risks of AI. We need experts from different fields, not just computer scientists, but also ethicists, philosophers, sociologists, economists to be involved in shaping AI. It can't just be left to the tech people. We need everyone's perspectives.
Like a global team effort.
Exactly. We also need to put resources into research on AI safety and ethics, develop strong methods to make sure AI systems align with our values and operate safely and predictably, and we need to be ready to adapt as AI keeps advancing.
It's a huge task, but it seems crucial.
I agree. Trying to build human-like AI is one of the most ambitious and potentially world-changing things humans have ever attempted. It could completely reshape our world, but only if we approach it wisely with a deep understanding of the human values that should guide our technological progress.
That's something to think about. We've covered so much in this deep dive, from the details of object recognition to the philosophical implications of creating machines that think like us.
And I think the journey's just beginning. As we keep pushing the boundaries of AI, we might find that the most amazing discoveries aren't about the machines, but about ourselves, about the incredible power of the human mind that we're just starting to understand.
That's a great thought and a perfect way to wrap up. Thank you for joining us on this deep dive into AI and human-like intelligence. We hope it's made you curious and inspired you to think about the future we're creating together.
As we go further into this exciting new era, keep exploring, keep asking questions, and keep pushing the limits of what's possible. The future of intelligence is in our hands.